Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the following equation is true. Okay, let us begin. So first what we're going to do, we're going to convert this equation into a statement. For this, we will suppose that let P of n be a statement. This is going to be a statement given by, the statement is going to be given by P of n such that we take the equation 1 over 2 multiplied to 5 added to 1 over 5 times 8 added to 1 over 8 times 11, and this goes all the way up to the last term, which is 1 over 3 times n minus 1 multiplied to 3 times n plus 2. This is going to be equals to n over 6n plus 4. Fine. We're going to label this as number 1. So this is how we can represent a given equation in the form of a statement. So we need to show by the principle of mathematical induction that the statement P of n is true, regardless of any natural number that we choose. That means for all n value belonging to the set of natural number, the statement P of n must be true. How do we show that? So first we will check the validity of the statement by taking the first natural number n equals to 1. So in that case, we get P of 1 such that we only have to consider the first term, since n equals to 1 corresponds to the first term, 1 over 2 multiplied to 5. This is going to be equals to, so here we have n over 6n plus 4, so we're going to replace n with 1 divided by 6 times 1, that's simply 6 plus 4. Now we see that 1 over 2 times 5, that's 1 over 10. This is going to be equals to 1 over 6 added to 4 also gives us 10, which means we are getting 1 over 10 equals to 1 over 10. And this tells us that P of n, the statement P of n is going to be true statement for n value equals to 1. So we have successfully verified that for n equals to 1, the statement P of n is true. Now what we'll do next, we're going to consider another natural number. So for n equals to m, we are going to suppose, we're going to assume beforehand that let P of m be true. Now what does it mean when we say that P of m is true? It simply means that P of m such that we take the first term 1 over 2 multiplied to 5 added to the second term, which is 1 over 5 multiplied to 8. So this is going to continue all the way up to 1 over, so in place of 3n minus 1 we get 3m minus 1. Replacing the n with m, and this is going to get multiplied to 3 times m plus 2, and this sum, the sum of these terms equals m over 6 times m plus 4. So we're saying, let's call this number 3. So we're saying that statement number 3, or can say the statement Pm is true. We're making an assumption here. Next what we'll do, we're using this, we need to show, using Pm, the statement Pm, we need to show that the next consecutive number will be Pm plus 1. That is Pm plus 1, that is also true. Now, to show Pm plus 1 is true means that P of m plus 1 must be such that we have 1 over 2 times 5 added to 1 over 5 times 8 going all the way up to 1 over, we have 3 times m minus 1 multiplied to 3 times m plus 2. But we're going to get one more term because we are considering the next consecutive term of m. So that's 1 over, replace that m value with m plus 1. So that should give us 3m plus 2. Multiplied to, we have 3m plus 2. We're going to replace this m value with m plus 1. That's going to give us 3m plus 5. So we have to show that this is equals to m plus 1 divided by 6 times m plus 10. Okay, fine. So what we will do, we'll start from the left hand side. So we'll start from the left hand side. So on the left hand side we have, now luckily for us, the first term all the way up to the second last term, this is nothing but m over 6m plus 4, because we have already assumed that P of m is a true statement, which means that we can replace this sum with m over 6 times m plus 4 added to, now we have 1 over 3 times m plus 2 multiplied to 3 times m plus 5. So what we'll do, we'll now combine these two terms. So what we can do here is we can take, now what is 6m plus 4? This is 6m plus 4. If we take 2 as the common factor, this is simply multiplied to 3m plus 2. Fine. So which means our common denominator will be 2 multiplied to 3m plus 2 multiplied to 3 times m plus 5. Which means that in the numerator, now we will be getting 3 times m squared plus 5m added to 2. Fine. Now what is 3m squared plus 5m plus 2? We can factorize the numerator. So the factorization by splitting the middle term is going to give us m plus 1 multiplied to 3 times m plus 2 in the numerator. And then in the denominator we have 2 multiplied to 3 times m plus 2 multiplied to 3 times m plus 5. So here we can factor out 3 times m plus 2 from the numerator and the denominator. So that is going to leave us with m plus 1 in the numerator. And in the denominator we have 2 multiplied to 3m plus 5, which is simply 6 times m plus 10. Or we can say we have m plus 1 whole divided by 6 multiplied to m plus 1 added to 4, which is the expression on the right hand side. This is what we needed to show, m plus 1 over 6m plus 10. So that means p of m plus 1 is also coming out to be a true statement. We'll say here that since the left hand side equals the right hand side, so this implies that p of m plus 1 is true. Now we can generalize our statement and we can say hence the original statement p of n is going to be a true statement for any values, or you can say for all values of n belonging to the set of natural numbers. So we have successfully verified the problem with the help of the principle of mathematical induction.